Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh and very good evening. My name is Muhammad Ali Hafizuddin bin Muhammad Najib. My matric number is 01dee22f1083. Today my presentation is about semiconductor device, subject code DE20023. So continuing this slide. Question 1 is about calculate the value of VP secondary, VRMS secondary, and I average. If V average is 110 volt with load resistance RL is equal 1.5k ohms for a full wave bridge rectifier. So continuing to the equations, for this uh, VP secondary is not given. So we need to turn our mirroring or turn out the equation to get the VP secondary. So first of all, I'm using V average second. I'm going to use V average equations. So in this slide, you can see V average is equal to V out divided by pi. So like I said, V average is already given in this question. So V average is equal 110 is equal to V out divided by pi. So turn upside down the equation, we, we put V out in the left side. So 110 is times pi divided by 2. So V out is equal 172.80. For V out, to search for VP secondary, we need to use the V out equation in the formula. So V out is equal VP secondary minus 1.4. But V out is already calculated. So 172.8 is equal VP secondary minus 1.4. VP secondary we put on the left side and 172 we put on the right side. So 172.8 plus 1.4. So we get the VP secondary is equal 174.19 volt. So continuing to the equation, is asking about VRMS secondary. So for VRMS secondary, we use the original formula VP secondary divided by square root. So VRMS is equal 174.19, that already calculated right there, and divided by square root. So the answer is VRMS is equal 123.17. For I average, using the formula, V average is divided by RL. So I average is equal to 110, that is already given, and divided by 1.5k ohms, like already given in the equation. So I average is equal to 73.33 milliampere. Continuing to the question 2. Common emitter configuration is shown in figure 1. If transistor BC107 used in this circuit is silicon type and beta is equal to 100. So calculate the I'm sorry. So we need to calculate the IB, ICQ, VCEQ, IC saturation, and VCE cutoff. So we continue with the question is IB. So IB is not given, but in this circuit is RB. There is two RB, so we need to plus them. So RB1 plus RB2 is equal to RB total. RB total is equal to kilo ohms plus 600 kilo ohms. So the answer is 602 kilo ohms. So KVL EMF is equal to V drop. So VCC is equal to VRB plus VBE plus IERE. VCC is equal IBRB plus VBE plus IERE. VCC minus VBE equals to IBRB total plus VBE plus IB in the bracket 1 plus beta RE. VCC minus VBE is equal to IB, RB plus 1 plus beta, RE. So the formula, the the Rumus will be IB is equal to VCC minus VBE divided by RB total plus 1 plus beta plus RE. So IB is equal 20 minus 0.7 divided by 602 kilo ohms in bracket 1 plus 200, 200. So the answer will be 3 IB is 30.05 microampere. For ICQ is beta times IB. So ICQ is 200 is equal to 100 times 30.05 micro. So the answer will be answer for ICQ is 6.01 milliampere. Continuing for the VCEQ. So VCEQ is VRC VA plus VCC is equal VRC plus VCE plus VRE. VCC is equal ICRC because we divided for searching for voltage. I'm sorry, I'm not explaining it the first time. So to expand the equation, we must divide it by if we want to search volt, so we need to use the Ohm's law. So for the Ohm's law is I is times R. So in this equation, IC times RC plus VCE plus IERE. Also the same for VRE. So VCC is equal to ICRC plus VCE plus ICRE. VCE, I forgot to mention, IC is equal to IE. So VCEQ is equal VCC minus IC in bracket RC plus RE. VCEQ is equal 20 volt minus in the bracket 6.01 milliampere times 2K plus 200. So VCEQ is equal to 100 volt, 20 volt minus 13.22. So VCEQ, the answer will be 6.78 volt. For IC saturation, we must put VCEQ is equal to 0. So VCC minus IC in bracket RC plus RE. So to mirror this equation, we put on the left side IC and we put the right side is VCC because we need to transfer the RC plus RE on the right side. So IC, because in this equation, IC is times RC plus RE. If we put on the right side, will be divided. So VCC is divided by RC plus RE. So IC saturation, the number will be 20 is 20. VCC is equal to 20 divided by 2K plus 200. IC saturation, the answer will be 9.09 milliampere. Continuing to the VCE cutoff, to find VCE, we must put the IC is equal to 0. So in the equation, VCE, VCC, so in disclaimer, I already put the IC is 0. So VCC minus 0 RC times RC plus RE. So 0 times RC plus RE is the same, is equal 0. So VCE is equal to VCC. So VCE cutoff is equal 20 volt. That's all for me. Thank you very much.